The first one, it says let and then a bracket, I think. Here, 1 second.
Tell him it just sent.
Okay.
Yeah.
So here, my mom just sent it, so it'll be easier to see it than to explain.
I got it. Let me do this now. Didn't want to let me zoom. You tell me where you want to begin.
The first one.
Okay. How would we graph that? Let's do it step by step here. How would you graph that system?
So you plug in 0 for y.
Okay.
So for x right now, so that'll be x is 6.
Okay, that's the x-intercept.
Right.
What's the y-intercept on that line? That first one.
So 4/5.
No, you're still working on the first one. This one here.
Oh, oops.
What's the y-intercept? In other words, we only have 1 point. I cannot draw a line with 1 point. I got to have 2 points.
Okay, so then that's 4.
Okay. Now I'll connect those 2 points.
Okay.
Here's the graph of the first line. Now let's graph the second line.
That way, you can go back.
For the second equation.
That's the only way you can prove it, right?
You can do it the same way. Graph the x and y intercept.
Yeah. So that's for x 10.
Let me use a different color for this one. Okay. And the y-intercept?
-2.
Okay. I'll connect those 2 points. Whoops. I didn't do a very good job of connecting them. But regardless, notice that they say graph it on a coordinate grid. If I graphed it on a coordinate grid, in other words, a proper grid with labels, then what's the solution to the problem? Where they cross.
Oh, yeah.
This is where they cross. Now, I don't know that it necessarily crosses on that x-intercept because I drew it a little funny. And I just approximated the grid. But this both highlights and shows you the problems with trying to figure out the system of equations graphically. In other words, I don't know what that point is. I can't read it. I don't know.
Right.
It could be 6 comma half. It could be 6 comma negative half. It could be 5 1/2. In other words, my grid system isn't accurate enough to read the solution graphically. But always remember that that solution of a system of equations, there's 3 ways to get it. You can get it using substitution, elimination, or graphically.
Right.
Okay. Now, so we know approximately where our solution should be, somewhere in that neighborhood. I'll leave that up there for a moment. Let's look at B. Estimate the solution to this system. All right. It's hard to do the way I drew it because everything was so approximate. Let's just 6, 0. Okay, we'll see how close the real solution is to that. Which of the algebraic methods would you choose to solve, and why?
Yeah.
Going to use substitution or elimination?
You want me to sign this to Michelle? No, I think it's
Elimination.
And so you
Correct. Why?
Because it's they're both in standard form.
Good answer. Where you use substitution is if I had the x totally defined. In other words, if I had written that second one like this, same equation, but here x is completely defined. It's only on one side of the equation, it's all by itself. If this is what they gave me, I would have used substitution. I'd have gone back to the first one and substituted 5y plus 10. So substitution is used whenever they're both in standard format. Elimination is just almost always the best way to go. All right. Solve the system using elimination. I'm going to call that equation 1. I'm going to call that equation 2. And there's a good reason I number them. Because a lot of times you end up with a page full of equations, and if you don't number them, it's really easy to get mixed up. So how do I solve this by elimination?
So you could multiply the number 2 equation by -2.
Okay, I like that idea. That gives minus 2x plus 10y equals minus 20. Notice you have to multiply every term on the left side and every term on the right side by minus 2. Now I'm running a line through that because that's no longer equation 2. I got a new equation 2. Now what?
So eliminate, I guess. So
well, the way you eliminate is you add the 2 equations. Okay? You can always add equations and subtract equations. Down here on the right, if I had a plus b equals c, and I had x plus y equals z, well, then I can add those 2 equations. A plus b plus x plus y has to equal c plus z. So I can always add equations. I can also always subtract equations. Either one. You don't always have to just add. In other words, we actually could have gotten away with multiplying equation 2 by 2 instead of -2. If I'd have multiplied it by 2, I'd have had a 2x there. And then I could have subtracted equation 2 from equation 1, would have worked just as well. But most people are far more comfortable with adding than they are subtracting. So I always think it's a good idea to multiply it by a negative number so that you'll be able to add the 2 equations and eliminate. Okay, so I'm adding equation 1 to equation 2. What do I get?
So the 2x and -2x disappear.
Okay.
And then so the 3y and 10y is 13y.
Okay.
And then the 12 and -20 makes -8.
So what's y?
-8/13.
Now, we still have to solve for x. Okay?
Okay.
You solve for x.
That's part of your homework. But your quiz is a homework, or are you actually taking the quiz tomorrow?
No, well, so it's the algebra, which is for homework, and then I also have to study something.
Go back and you substitute what you got for y into either of those two equations.
You're working on that middle
And
piece
you
of
solve for x.
All right. So,
Which equation are you going to substitute it in? You got the original one, the original two, or the new two? Which one is going to make it easiest to solve for x?
the original number 2.
Yeah, the one that's got the smallest numbers in it, pretty much, and positive numbers. In other words, I prefer positive. I wouldn't have minded 1 because everything's positive, but x doesn't have a coefficient here, and that's going to work to our advantage. So we've got x minus 5 times a negative 8/13. I'm substituting what we got for y, equals 10. Solve that equation.
Okay. So that would be x plus 13. What's 13 times? 13 times
5 times 8.
Oh, that was 40. So 40 over 13
Okay. That's
equals 10.
10. The next step.
Then subtract 40 over 13 from 10.
Can you do that without a calculator? How would you do it? How would you take 40/13 away from 10?
You could turn, so 10 is technically 10 over 1, so that's a fraction. So then you find, I think you find a common denominator.
Correct.
Subtract.
Correct. In other words, I'm going to pick it up over here. So I'm going to turn the number 10 into some number of 13ths. How many 13ths is it?
1/13.
130 over 13.
Oh.
Notice that's the number 10, right?
Yeah.
In other words, I could divide both top and bottom by 13, and I get 10 in the top over 1. But now I have a common denominator, and I can subtract 40/13. So what does that end up being?
90 over 13.
Okay. Let's see how that compares with our answer, our estimate. The x-coordinate is about 7, almost 7, 6.9. And the y-coordinate is like minus a half. So the true coordinates were essentially 7 minus approximately a half. Well, we weren't that far off. We guessed 6, 0, and you can kind of see that I drew my green line with too much slope. Should have drawn the green line more like that to go through that point. And now you can see where they cross is closer to 7, minus a half. Now, I've rounded these off. The true answer is 90/13 is the x-coordinate, and minus 8/13 is the y-coordinate. Okay? So that's the answer they want. Does the solution in part D match your solution in part B? And the answer is no, it does not, because I didn't use a grid. Notice though, actually it does not, because it's too hard to read the exact number in a grid. How? I can't even imagine a coordinate grid where I would have been able to figure out where 90/13 was, or where -8/13 was. So even had I had a proper grid that was labeled, it would have been still very tough to figure out the solution from the graph alone.
Okay.
Graphically is not the best way to do these problems. Either elimination or substitution. In other words, the algebraic methods are.
Okay.
The reason they introduce the graphs to you is to show you that where those two lines cross is the solution. All right, let's look at number 2. Let me scroll up a little bit here. Zoom go away. There. All right. Graph the following. All right. When you are graphing a piecewise function, which is what A is, the way you kind of want to do it is the following. Let me do it conceptually for you first. Start right there, always. Okay? If I put the point -2 on there, what I'm doing is anything to the left, this is an imaginary dotted line, not a dotted line that's going to end up on my graph. But I'm saying that whenever x is in that region going all the way to -infinity, I'm going to have that first function.
Okay.
1/2 x plus 4. Now, notice that I'm not going to cross the y-intercept, right?
Right.
I can't really start at 4. I could start at 4, draw the line, and then erase the part that doesn't belong. That's not really the best way to do it. To figure out where we're going to cross this dotted line, plug in x equal -2. I'll show you. Into that equation right there. Even though it says x is less than -2, still plug in -2. What's f of x when x is -2 in that first piece?
So 1.
Okay. -1.
Yes, -1.
Plus 4 is what?
5.
No, -1 plus 4.
3.
Okay. So what I know is that when x is -2, y is 3. So I know where to start that. Should I start it with an open circle or a closed circle?
Closed.
Open. Because it's less than -2.
Okay.
Okay. If it was less than or equal to -2, then it would be closed.
Right.
That's what makes the difference. If it's a less than or equal, it's closed. If it's a less than or a greater than, it's open. Okay. Now, how do I draw the rest of that line? That's just one point. That's where it starts. But the rest of it goes to the left. So how do I get a second point? What's the slope of that line?
So that's the slope is 5?
Y equal mx plus b.
Right.
That's point slope.
F of x.
M is the slope. So what is the slope of this line?
3. No.
What's the coefficient of x?
0.
All right. There's the coefficient of x. That's the slope. M is the slope. So we're talking about this equation right here.
Yeah.
What's the coefficient of x?
1/2.
Okay, that's the slope. Now, how do I draw that slope going to the left? A slope of positive 1/2. I got to go down and left. How much do I go down? How much left do I go?
Down 1, left 2?
Yeah. Which gives me that. And that thing goes to infinity. Okay?
All right.
Now, let's deal with the next region. The next region, in other words, this part here. And this is the order I do it. I start in the upper right and detail out what my domain is going to be. Okay, well, the next region goes from -2 to 3. So I'll put an imaginary line going through 3. And you can just think about it this way. You don't necessarily have to put the line in there. But the next function is this area here. That's the way you need to think about these piecewise functions.
Okay.
Okay? So whenever I'm greater than or equal to -2 or less than 3 on the x-axis, I've got this middle function.
Okay.
Let's see if I can erase this easily. Something's wrong with my eraser today. Something's wrong with my stylus. Now let me get rid of as much of it as I can. Okay. Now I'm going to go to a new page. Can't do that. I won't go to a new page. Let's see. I'm going to work down here in the lower left. Okay. We need to figure out how to graph that function. What's the parent function? The best way to graph this function is to figure out the parent function and the reflections and transformations that this function represents versus the parent function. What's the parent function?
-2.
Parent function is an elementary function. By that I mean it's that part of the function without the minus sign, without the 2, without the -1, and without the +9. Each of those is a transformation of the elementary function. Okay? So down here, I'm going to draw one by one. The elementary function, that's what it looks like. Slope of -1, slope of +1. In other words, it looks like a V. And there are arrows on it. Okay? That's what the elementary function looks like. However, we got a lot of stuff going on. And you always do your reflections first. So in a different color with each step, I'm going to do, first one I'm going to look at is that negative sign. What does that mean? What kind of a reflection or transformation is that?
So it's it flips upside down over the x-axis.
Right, which I call a vertical reflection.
Okay.
And it's useful to look at it as vertical because it ends up being that everything that's outside the standard absolute value markers is a vertical transformation. Everything that's inside is a horizontal transformation. So there's a total of 6 of these things. It's quite useful to be able to break them down into 3 horizontal and 3 vertical. But I call the reflection a vertical transformation.
Okay.
Or a vertical reflection, rather. So that would be y equals negative absolute value of x. Okay? I know this is hard to see. I'll try to use a little darker pen color here. The next one I'm going to do is I'll do it black. Okay? Now we're just going to go left to right and deal with each one as we come to it. So the question is, what is the graph of minus 2 times absolute value of x? At the end, you put them all together, but it's very useful to do these transformations one at a time. That's the way you would do it if somebody said graph it. You just do them one at a time. What's the 2 do?
The 2 moves it to
First, is it vertical or horizontal?
Vertically.
Correct, because it's outside the function. And I'm going to tell you it's either a stretch, a vertical stretch, or a vertical shrink. Which is it?
Oh no. You're like, what the hell? No wonder they didn't want to play.
Vertical shrink.
Stretch. When it's vertical and it's greater than 1, it's a stretch. Okay? Now, what the stretch does is it makes it narrower by half.
Oh, this is that bad.
Okay? You might think that's a shrink, but that's actually a stretch. Okay?
Okay.
A shrink would make it flatter. In other words, if instead of, say, a half, it was 1/3, then I would have flattened it out, make the V wider instead of narrower.
Okay.
All right. Different color. What's the darkest color we got here? This one right here. Y equals minus 2 times, let's take the next thing we see, the x minus 1. What does that minus 1 do?
Okay. You're all be kindly.
It.
First of all, is it horizontal or vertical?
Horizontal, I think.
Yeah.
Yes, because it's inside the function. Anything that's inside the function is horizontal. Now, is it a shift? Is it a stretch or is it a shrink?
So.
Oh no.
Shifts don't change the shape. Stretches and shrinks do. Shifts merely mean go left or right. Vertical shifts go up or down. Take exactly the same last curve and just shift it. If I'm stretching it, then I'm changing the shape of it. The reason the 2 was a stretch because it was multiplying. The reason the 1 is a shift is because it's being subtracted. If it was being added, it would still be a shift, a horizontal shift. And because of the negative sign, which way does it go? Go right?
To the left.
Actually, to the right.
Oh.
When you see a negative, that means you're moving to the right by 1 unit. So I'm going to move it to here. Same exact shape as the black line. In other words, I haven't changed the shape. And that is what that function is, the purple graph. We only got one more thing to do, and that's to add 9. All right, what color should we use? Brown, dark brown. Okay, so I got to graph this now. Minus 2 times x minus 1, that's our purple line. We're going to add 9 to it. What's that plus 9 do?
It shifts it up, or, well, that.
No,
Yeah.
first of all, I forgot to ask, is it vertical or horizontal? It's vertical. It's outside the function. Is it a shift, stretch, or shrink?
Oh, great.
Shift.
Yeah, shifts are things that get added or subtracted. Stretches and shrinks are numbers that multiply. But this is not multiplying. I'm adding 9. So I'm going to take this, take the vertex, move it up 9 units to right there, and graph it. Same shape. This is the graph that goes in my space here. Okay? So I know where the peak of that graph is. It's at 9, and it's over 1 unit. And I'm going to approximate the shape. Open or closed on that end?
It is closed, I think.
Correct. Because it's greater than or equal to -2. In other words, whenever x is -2, I'm using my brown curve, not my pink one.
Right. Okay.
Now, the only thing tricky about that was I had you plug in 2 to figure out where that point is, which is proper. Even though this line is only when x is less than -2, but you still plug in 2 to figure out where you started. Now, over here, this thing isn't going to go all the way down. It's going to stop somewhere there. Open or closed?
Open.
Right.
I think.
Yeah.
The reason it doesn't go all the way down is because I don't have equal space to the left and to the right of the vertex. Okay? Now, I'm going to label that. That should be 1, 9. Okay? Let's test it. Plug in 1 into that equation right there. For x, what do you get for f of x?
Yeah.
So f of x equals -2.
Right? Yeah.
Always plug in the 1 first, because if that thing turns out to be 0, you just cross out that whole thing.
Yeah.
Okay, so I was just alright. So f of x equals -2, and then the lines are absolute value.
Here's what I meant. Here's what I meant. Whenever you're plugging in 1 for x, do it immediately. Forget the -2 for a moment. When I plug in 1 for x, that goes to 0, right? And 0 times any number is 0. So I get to cross that thing out, the whole thing, by plugging in 1 for x. And the result is f of x should be 9. Well, that's where we've got it.
Okay.
Okay. Now, tell me where this y-intercept is right there. I just want to know to see if I've graphed it properly. How would you tell? How would you calculate it? Based on our function. Here, let me go back and trace that line I drew through there.
Example 2, right?
What's true about x when you're on the y-intercept?
Right?
On the graph that I've circled, what's the x value at the point right here?
Oh,
0.
Okay, that's always true. Y-intercepts are where x equals 0. That's a truism that's always true. X-intercepts are where y equals 0. It's real easy to plug in x equals 0 here, so we can figure out the y-intercept pretty easily. Plug in x equals 0 and tell me what you get.
Okay, so
how's Kira doing with another brother?
Start with inside the absolute value first.
right, so -1 minus 1, so that's -2
Oh,
No.
times.
What you're plugging in is 0 for x. So 0 minus 1 is -1. Now,
Oh,
the absolute value of -1. In other words, I don't want you to start on the left. I want you to start with the hard part, which is the absolute value part. It's kind of like
okay.
being inside of parentheses. The idea is you want to get rid of the parentheses first. Well, if I plug in 0, I get 0 minus 1. So that
Right.
becomes -1. What's the absolute value of -1? +1. So
Right.
now I've eliminated the absolute value sign, and I have -2 times +1 plus 9. What is that?
I need my gravity, please.
So then 8.
-2 plus 9.
Oh, 7.
So that point is 0, 7. I'm a little bit off with my graph, but not much. As long as I label the points, it's not so key what my graph looks like. What's important is what those points are labeled. Okay?
All right.
Hold on a minute. Let me create some more drawing space here. It's hard. My eraser isn't working. But you get the idea. Yeah, okay, that's not bad. Now, I didn't find this point. I didn't find the x-intercepts because that's a little harder. In other words, I've got to set y equal to 0 and solve that equation. Okay? Let's not do that at the moment. That's a lengthy procedure, and we're moving slow enough as it is here. So, I mean, these are hard enough that we have to move slow. So now I'm down to the third piece, which says, what region is this? I hate the way they did this, but in other words, this right here, what region is that on my graph? X is greater than or equal to 3. This line is at 3 right here. That's plus.
Right. So it's anything further from that.
To be more specific. Further doesn't make sense. Is it right of my green line? Is it above the pink line? Where is it?
It's on the right of it.
Okay, so it's this area going all the way to infinity. In other words, it's from the vertical line, x equals 3, all the way to the right. That entire region, we're going to graph this function. Well, how do you graph f of x equals 2? How do you graph that?
So you put, so the, sorry, the x intercept is 2.
No. Vertical lines are x equals some number. Horizontal lines are y equals some number. Notice there's no x in that. It's y equals 2. That's a horizontal line at 2.
Okay, yeah.
Hold on. Well, call it that. Okay? At this point, is that opened or closed?
So, closed.
Correct. So there's your graph. Now, you don't need these 3 circles that I have here. that is probably a little confusing. I would try to erase them, but that's going to be hard, easier said than done. These three circles are not part of this graph. I was just circling it to point out that it would be nice to know what the coordinates are, where we cross the y-axis, and also the x-coordinates, where we cross the x-axis, which we didn't do. But you can see that's our graph.
Okay.
That's how you do it. In other words, start with your domain and work your way left to right. And then whatever is the area of that domain, graph that function. And you have to know how to graph these elementary functions. All three of those are elementary functions. You need to know how to graph these on their own. Not just as part of a piecewise, but if I gave you this alone, you should be able to graph it.
Okay.
Demetrius, I'm going to do something. I want to show you this thing. I might have already. Did I do this last time we met? You won't know until I bring it up here. I can't remember. I've had so many appointments this week. I don't know if it was you or somebody else.
Yes, we did. It was.
You were the one that did fantastic on this, but you don't do fantastic when you're solving equations. I don't understand that. What's this answer?
Negative 12 or 12. Zero.
You do not want to be using a calculator when we do this. My whole point with doing this is to get you so you can do these in your head accurately.
Yeah, I'm not using the calculator.
Okay. No, I believe you.
So, negative 11, I think.
No.
Negative 12 plus, plus negative 9. Okay, so.
When you add two negative numbers together, just add the two numbers and then put a negative sign in front of it. So it's negative 21. In other words, It's 12 plus 9 is 21. And since they both have negative numbers in front of them, it's negative 21. Gone?
Negative 90.
This is the same as negative 9 plus negative 7.
Okay, so negative 16.
Yeah. And this is what I tell everybody to do. First of all, let me get some writing instrument here. The reason people have trouble with this specific problem, and they do, half my students would probably miss this problem. It's because you're looking at two negative signs, and yet they both mean something different. This negative sign means subtraction. This negative sign means that's a negative 9. Okay? So what you want to do is change all of your subtraction problems to addition problems. I can do that by just making that read plus and changing the sign of what was being subtracted. So now, look what I have. Negative 9 plus negative 7. Nobody misses that. What's that?
Negative 16.
Yeah. So if you do that, you don't have to necessarily do it for all subtraction problems. If I told you what's 9 minus 7, you don't have to change it to an addition problem. You know how to do subtraction problems, but all of a sudden if you throw in a lot of negative signs, it complicates it for people. And so if I put a negative sign in front of there, now I would say change it to an addition problem. Well, In order to do that, you have to know which one is the subtraction sign. This is the subtraction sign. Okay?
Okay.
All right, let me exit this. Go back to your page. And moving on. Let's do B. First of all, the way you kind of want to graph these is as an equation. Okay, that's linear. In other words, is all we have is x to the 1 power. I don't have x squared or x to the 1/2. Anytime you just have x to the 1 and y to the 1, you have a linear equation. It's going to be a straight line. What's my first step for graphing that? Let's say, first of all, I'm going to turn it into an equation. But in order to graph it, what's a nice, easy way to graph it? Put it in this format.
Right. Okay. So
it's not in that format right now.
So
get rid of the parentheses.
All right. So 1/2 x.
I think that's a third. I think that's a third.
Oh, that's a third.
Uh-huh.
Okay. Yeah. That is a third. Okay. So 1/3 x plus 4/3, 4/3, and then plus 1.
Okay. Now, what? Keep simplifying because I can do more.
Okay. So then that's 1 4/3.
No, okay. Yeah, you could do it like that. Sure. No, that works. Not really. It's 7/3.
1/3.
Write it as 7/3. I don't.
Yeah.
1 4/3 at the very minimum should be 2 1/3. If you're going to write it as a proper fraction, it's 2 1/3. If you're going to write it as just a fraction, it's 7/3. I prefer improper fractions myself. Ratios are where it's at from here on up in math, not decimals, and not proper fractions. Improper fractions are what you're going to deal with in trigonometry the whole year. Okay. Now, I got to graph this. Okay. First of all, if I graph it as a line, I would be graphing the equation. And it's not an equation, it's an inequality. So,
Right.
I'm going to have a solid line or a dotted line?
A dotted.
Correct. Where do I start?
So
Graphing this lower black one.
So at 7/3.
Correct. Always at the y-intercept. Okay, I'm going to call that 7/3 right there. Okay, there's 1 point on my line. I need 1 more point. How do I get it?
The slope. So
okay. Tell me what I got to do.
You go up 1 and then right 3.
Perfect. Say that's it right there. Notice that slopes that are less than 1 are flatter. They're not 45-degree lines, 45-degree angles. They're flatter. That's why a horizontal line has a 0 slope. So there's my graph. Now I have one last thing to know. I got to shade one side or the other. Don't forget about shading. Types of lines, open and closed circles. Well, we've talked about types of lines. We've talked about the open and closed circles. Now I got to shade because it says y is greater than that line. Which side do I shade?
Above.
Correct. In other words, the only thing you ever do is look to the y-axis. That's all you have to do. It's So all you have to see is that right there. Nothing else. That says y is greater than this line I just drew. Okay? But it's not a solid line, it's a dotted line. I drew it as a, even after you told me dotted, I drew it incorrect.
Let's say that. So I have to do a like. I have to do a span.
Okay, so there's our line and we're shading above. And the answer to that question is almost always either above or below. It is very seldom right or left. The only time the answer would be right or left is if you were looking at a dead vertical line, straight up and down. Otherwise, the answer is always above or below. Even if I have a situation like this.
Why don't you look at a map?
If I ask you which side of that to shade, you're not going to answer right or left. You're going to answer above or below, and you're going to look at the y-axis. So above the line would be over here. Below the line would be over here.
Right.
Okay.
Travel by just roads. Okay, so you need to, you know what I mean?
Okay, what we're looking at now is they give us the piecewise graph, and we have to come up with the piecewise function. In other words, number 2a was the other way around. They gave us the function, we had to graph it. Now they're giving us the graph, we got to come up with it.
So you want to look at.
Let's first of all, there's actually a couple of ways you could do it. In other words, I can treat 3 separate regions. That region,
Whatever, you know.
that region, 4 separate regions. That region, and finally that region. Those are our 4 regions. So when we go to graph it, let's do it this way. This is by far the easiest way to do it. So for me to write the piecewise function, I'm going to start with that spot right there. On this graph, what is that? What should that say?
You need Spain to Australia.
So
About
x, so wait.
What's this point right here? It's like -1, -2, -3.
Yeah. So x is 3 or -3?
Oh, I'm dealing with this region.
No.
So x is what? Look at the example of the first one they gave you.
Oh, x is less than -3.
There you go. That describes the domain for that first chunk. Okay.
Okay.
Now we got to figure out what the equation of that line is. Well, what's its slope?
So it's 1/3. So up
Well, it
1.
actually looks like 1. In other words, I go up 2 and over 2. Or, excuse me, I go up 2 and right 2.
So are they
Clearly negative, so the slope is -1. So on this first equation we're going to write, we have a slope of -1.
they didn't go to France and say, we'll tell you this? No. And then
Now, there's a couple ways you can do this. If I knew the y-intercept, I'd know the equation of the line, right? We still have y equal mx plus b. Problem is, this line doesn't go to the y-intercept. But I know its slope. If I were to continue it, it would end up right there. So what would the y-intercept be? If it were a straight line all the way to the y-intercept, what would it be?
2.
Read it off where, what is this point? Can you see the grid?
Oh, yeah. -3.
Uh-huh. So what's the equation of that line?
So y equals 1, or x minus.
Actually, excuse me,
Wait.
that's a negative slope. I forgot to put the negative sign in front of it. So
So
m is minus 1.
So -x minus 3.
Correct. That's the equation of a line. And it's the equation of our line. The only difference is it doesn't go all the way to the y-intercept, but that doesn't change the equation of the line. In other words, there would be other ways to figure out the equation of that line. I could use point slope, but that's more complicated. The easy way, especially when you have slopes of 1, is just imagine it being extended as a straight line. Where does it hit on the y-intercept? Clearly at -3, as it should. If it's a slope of -1, this point would go all the way to -3. Now, what is our next region, which is defined between this point and that point? So x is what?
So
We'll get back to whether these should be greater than or equal after we finish. I'll explain that. But
okay.
mainly I want you to think, okay, now we're this area right here
Right.
defines our domain. So what is the domain? That's always where you want to start. You don't want to start with the function. You want to start on the right on these.
Okay. So
What's x greater than?
x is greater than -3.
What's it less than?
And less than 0. Or, yeah, 0.
Okay. What's the slope of that line?
1.
Okay. What's its y-intercept? It does touch the y-intercept, so we don't have to extend any line. We can look at it and count.
It's at 3.
Okay. There's your equation. Okay. What's the next domain? X is greater than what and less than what?
So x, or sorry, yeah, x is greater than 0, but less than 1.5.
The x coordinate at that point right there.
Yeah.
3. See, the hash marks are very faint, but there's 1, there's 2, there's 3.
Oh, I was, okay, yeah.
Okay, so that's our domain. Now what's the equation of that line? What's its slope?
So the slope is
Negative for sure.
Yeah, negative. So down to right 1.
Okay. So what kind of a slope is that?
Negative. So I don't.
Rise over run. Down 2 over
Right.
1 means 2 over 1. We can see it's a negative slope, so the slope's got to be -2. -2 over 1. That's why everybody says up and over, is because you're looking for a fraction. What it really is 2 over 1. But that's not the correct way to describe how to find it. But it just occurred to me after 8 years of tutoring, I finally figured out why everybody says up and over when they shouldn't. But anyway, so we have our slope. What's the y-intercept? What's B on this one?
So B is nothing. 0. Right?
B is the y-intercept.
Or so
Not the
3?
x value. Yeah. It's the y value when the line crosses the y-axis. I know the x value is 0, always, but the y value is b. So b is 3. That makes the equation of that line minus 2x plus 3. Almost done. I only got one more zone. What is it?
So
This last area here.
so x is greater than 4?
What's the point that it starts at?
Oh, sorry, 3.
Okay.
And then
X greater than 3. Now,
yeah.
Because there are no blanks, this is a continuous, we still have to figure out the equation of that line. I'll get to that in a moment. But we're past the time, and I want to explain something about whether we're using greater than signs here or whether we should be using greater than or equal. The problem with the way I've done it is the thing isn't defined at all these corners because I've said greater than. So let's just change them. Let's just change them all to greater than or equal. And that's okay because it's continuous. Now it's accurate. I still have to put that last equation in. And that last equation has a slope of plus 1/2. So it's 1/2 x minus whatever that would extend to. Let's see. If it's 1/2, it's going 1, 2, boy, those are hard to see. 1, 2, 3, 4, 5. So you know how I'm going to figure this out? The other way. Well, I don't have time to do it the other way. Whatever that ends up being, let's call it 5. Okay? I don't know that that's right, but we're out of time and I have another session. So I can't finish the 4th piece. Okay? Now, there is an alternative for doing 4 pieces here. I could treat that as the absolute value function and do just one function there. And I could treat that as the absolute value function and do one function there. So I could have done this in 2 pieces instead of 4. It's just a little more complicated and conceptually harder to picture. You know how to graph straight lines. Graphing absolute value functions is a little harder. Or figuring them out from a graph is a little harder. Okay? All right, Demetrius, I will let you go, and I will talk to you next week.
Yep.
Yeah, we did the right times, right? We were from 4 to 5. Okay, yeah.